come back to the whiteboard. Caramba. Whiteboard. Now. Anthony Suarez. Okay, guys, we continue the same topic that we discussed last time. I bring, a little bit more complicated examples. So we are discussing linear, non-linear system of equations in 2 dimensions, and today we studied 2 dimensions and 3 dimensions. Because unfortunately, we need that in calculus 2 and calculus 3. The student can need to take calculus 3 in 3 dimensions. Okay, this example is a little bit sophisticated. Look, x squared minus y squared minus 4x plus 6y minus 4 equals 0. This is my first equation. And my second equation is x squared plus y squared minus 4x plus 6y plus 12 equal to 0. Equation 2. This is my system, non-linear system. And remember, non-linear is different to linear. In linear, we have only systematic way. You solving, elimination, substitution, and you always get the answer, obtain the answer. And non-linear, there are no rules. This is
Professor, you're muted.
Professor, there is no sound for you.
suppose que somebody press mute. Okay. Okay. Thank you. Okay. I explain when you have no sound, okay, this is complicated example. Because you try to subtracting equation 1 minus equation 2, or addition, equation 1 plus equation 2, you don't get nothing. Entonces this is a little bit sophisticated because you need to apply completed the square. Completed the square. Let me explain the idea behind completed the square. You take the first equation and you try to group in the x separately, so minus 4x. You take x and complete the square. And the y and complete the square. Entonces minus y squared minus 6y, because I factor out -1. Here the sign I put outside, plus a box. Minus 4 equal to boxes. I don't remember if you see before with me complete the square, but this is called algebra, no? Okay, that's easy. It's easy. It's you take the coefficient get b divided by 2 and square, and this is the magic number. Magic number. And this is scenario 4. I don't care the sign is not important. 4 divided by 2 is 2, and 2 squared 4. This is the magic number that completes the square at least of this trinomial. Okay, likewise, in the y part, 6 divided by 2 is 3, square 9. Okay, also, so now in order to, I create artificially this red number, 4 and 9, in order to don't change my equation, you adding 4 and negative 9. Remember this guy, this negative I put here, get actual is positive, actual is negative because we have negative outside. But the factorization is x minus 2 squared, we come from 2x square root 4, minus y minus 3 squared equal, see I move this 4 to the other side, we have 4 plus 4 is 8, 8 minus 9 is negative 1. And this equation is equation 1, but expressed in a different way, using the completed square. Do you understand this one? Come on, guys. Do you understand this one?
Yes.
Good. Let's doing exactly the same in the equation 2, and you see surprise. In the equation 2, we have x squared minus 4x plus something. In this case, not necessarily minus, it's plus. Sign it plus y squared plus 6y plus box. Entonces you have in the right hand side, you have two boxes. Minus 12. Because is this 12. I move to the right hand side like a minus 12. And it's similar. This magic number 4, this magic number 9. Entonces the factorization, this trinomial is x minus 2 squared plus this is y plus 3 squared equal, sorry, this is 4. And it's a 9, get together 13 minus 12. This is my new equation 2. I copy now together equation 1 and equation 2 is x minus 2 squared minus y minus 3 squared equal negative 1. Equation 1, I copy. Entonces in this case I can see clear okay, if this guy is ready to be elimination, if you multiply this equation by negative 1, because I want to change the sign, it's a minus x minus 2 squared plus y minus 3 squared equal positive 1. This is my new equation 1 now after the multiplication by negative 1. If you put together 1 and 2, so this and this, it's ready for elimination. This part disappears. And we have so far y plus 3 squared plus y minus 3 squared equal to, because 1 plus 1 is 2. Entonces in this moment I have one equation that contains one variable. Okay, why? You expand that. This is square the first plus twice multiplication on both plus square the second, get 9 plus y squared minus 6y plus 9 is the same, but this is negative and this is positive, and this only affects the middle term. Okay, negative 6 equal to. Everyone follow me so far? Oh no? This is cancel. This is 2y squared. Combine like turn this and this together is 2y squared plus 18, no? Because 9 plus 9 is 18 equal to. Okay, now solve for y. Look like quadratic equation. Now, well, you 2y copy. is equal to minus 18. 2y squared is equal to minus 16 divided by 2, both sides, and negative 8. So y squared is equal to minus 8. So you apply square root both sides because my goal is solve for y, or for x, is it's imaginary. It's plus or minus I because it's negative inside the radical, and in radical a or whatever you want is plus or minus 2i radical 2 because you know the a is 2 and 4 and radical 4 is 2, the 2 outside is 4 and the 2 stay inside is 2. But the problem is it's imaginary. I say you when you're solving something and the answer is imaginary, it's because no solution. Wow, too much work to get no solution. Do you understand this or no? Guy, question. I don't finish because always I want to check in my problem to make sure that we are doing well. Because no, somebody make a mistake. Somebody make it one, you change one sign, so the answer is completely different. En Desmos, remember, en Desmos we can verify, see your problem is good or no. Let me try to switch into Desmos. Okay, where is Desmos? Okay, in the same window. Oh yeah, I understand. Here, over there. Switch it to Desmos. There you go. Do you see Desmos? It's the same script. Okay, we worked before. It's the problem number 7. Look, problem number 7 is this equation. When you graph it out, look, the orange equation is a hyperbola, and the purple color equation is a circle. And never touch, no solution. Do you see or no? Question, guys, clear or confusing? Hey.
Clear.
Yes, clear.
Answer me. Okay, do you see whiteboard or not yet?
No.
Not yet.
May I? No? No?
No, we don't.
Oh, yes. We know. Now?
Yes, we see.
Yes.
Now, yes? Yes. May I erase or no?
Yes.
Yes.
Okay. Let's move on to examples 8. Example 8 is, the previous was 7, now 8. This is relatively easy. X minus 1 squared plus y plus 1 squared equal 5. And the other is 2x minus y equal 3. Equation 1, equation 2, system. Remember, guys, I explained that when you have this, the first equation is a non-linear, and the second equation is linear. So you take advantage the linear. You apply substitution. You're solving the variable que contain coefficiency 1 or negative 1, que by the way is the y. You solve for y in this equation, you copy that. 2x minus y equal 3. Therefore, 2x minus 3 is equal y. And you substitution this expression here in the y place of the another equation here, over there. So my equation so far is x minus 1 stays the same. Plus, no y anymore, no. It's 2x minus 3 plus 1. Square equal 5. Okay, nice. X minus 1 square. This is 2x minus 2, because minus 3 plus 1 is 2 square equal 5. Okay, and we can do something. Well. I factorization, I take advantage. There are many ways to solve this. It's quadratic equation, but in this case, I can see one easy way, is you factor out to here, x minus 1. And you square, this is 4, because 2 square, therefore x minus square equal 5. And we combine like term. This is like term, the same variable, the same exponent, the same everything. And this is 1, and 1 plus 45. Divided by 5, x minus 1 square equal 1. Well, in this case, I take advantage, it's a factorization, and you apply square root both sides. X minus 1, because you know, okay, square power and square root undo each other, and square root 1 is plus or minus 1. Therefore, x is equal 1. I move this one to the other side, plus or minus 1. Plus or minus 1 is 1 plus 1 and 1 minus 1. No? The answer is 2 or 0. Associated with the x value, I substitution here in order to get the y value associated. Suppose add x equal to, plugging into here, y is equal to 2 times 2 minus 3. 2 times 2 is 4, 4 minus 3 is 1. And the point is the point 2, 1. Super. Add 0. Y is equal 2 times 0 minus 3. Y is equal, y equal minus 3, and the point is the point 0, negative 3. Boom. So we expect two solutions. See, you analyze geometrically, this equation number 1 represents circle. This is the circle. To understand geometrical, no? And Desmos you can see clear. It's a circle with the center. It's located at the point 1, negative 1. It's a circle somehow, and this line, and circular line, not always, but sometimes we have two solutions. See, the line never touch, no solution, and see the line touch tangent is one solution. But in this case, two solutions, this and that. Let me try to show you the idea, the geometry idea in Desmos. No? Okay, I want to switch into Desmos. Okay. I suppose you see Desmos, yes or no? Example 8. Look at that. Example 8. The first equation is the red color. Is a circle. And by the way, the center of this circle is located at the point 1, negative 1, 1, negative 1, 1, here, over there, approximately. There you go. And the solution is the intersection and between the equation red, que is the first one, que is a circle, and the equation blue, que is a linear, que is a line. And the solution exactly is 2, 1 and 0, negative 3. End story. Any question, guys? So this is crazy. This is crazy. Don't worry for the crazy, because in a few minutes I want to explain. Well, we always can verify using Desmos, no? However, I want to explain another thing, another way, another resource that we can use in the test, in the review, and everything, in calculus. Okay, does everyone follow me or no? Totally lost? Complicated? Huh? Clear? Wow. Good to see that. To say that. Okay, let's move on to number 9. Example. Number 9 example. Number 9 and number 10. And 2 variables. And we have 2 more examples and 3 variables. Okay, entonces es 9. The first equation is 2x squared plus xy equal 6. Equation 1. The second is x squared plus 2 times xy equal to 0. Equation 2. Both equations are non-linear. Maybe it's confusing and you believe it's linear. No, the multiplication x times y is non-linear because this exponent is 1 and this exponent is 1 and the degree of this expression is 2. It's 1 plus 1. It's the sum of the exponent. So both are non-linear equations. And those are non-linear. The most frequently idea is elimination. So now there are many ways to do that. However, I take this equation. There are no unique way. The professor I'm doing in different way. Okay. A multiplication by -2. What is the intention? This -2 times 1 and -2 here and +2, and you eliminate the complicated term is xy multiplication. When you multiply by -2, we have -4x squared minus 2xy equal -12. And this is the new equation 1. And we're working now using 2 and 1, a new one. And this is ready for elimination. This is -3x squared. This is cancelled out. That was the intention. And it's inheritable. 0 and -2. Divided by -3 both sides. X squared 4, positive 4. And when you apply square root, we have two solutions, plus or minus 2. Okay. So now this is a moment to do substitution. For example, at x equal +2. You plugging in the easier equation. Okay, my opinion is this one. Because I take advantage, get 0 on the right hand side. No? So es 4, 2 squared plus 2 times 2y equals 0. It's 4 plus 4y equals 0. And so 4y. So 4y is equal to -4 divided by 4. The answer is -1. In this moment, you matching. The point is 2x and y -1. So the point is 2, -1. This is solution. The second solution, similar. At x equal -2, same equation. Be careful with the sign. Is -2 squared plus 2 times -2y equal 0. Okay, this is 4 positive. This is -4y equals 0. Let's solve y 1. Let me try. 4y equal -4 divided by -4 both sides. Y 1. And the point is the point -2, +1. End the story. Let's verification this in decimals. Okay. Actually, in Desmos, let's try Desmos, switch into Desmos. Okay. Okay, it's example 9, no? 9, look at that. We have two equations. The black equation is the, hyperbola. Rotate a little bit, hyperbola. The second, no, the second is a line. At the beginning, I don't see it as a line, but actually it's a line. Because you solve for y, somehow eliminate the square. But the intersection is the answer that we get. 2, -1 and -2, 1. Any question, guys?
No question.
No? Okay. Let's move on to example number 10. Example number 10 look like horrible. However, I want to solve it in one fantastic way. It gets too easy. Okay. Easy whiteboard? Yes or no? Answer me, please. Yes. Yes. Okay, look at that. The example 10 is look like horrible. However, we're doing transformation to see easier. Example 10 is 3 over x squared plus 1 over y squared equals 7. This is my first equation. And my second is 5 over x squared minus 2 over y squared equal -3. Equation 2. This is the system. It's obvious it's no linear. It's no linear. Exponent 2 actually is -2 because in the bottom it's crazy, totally crazy. However, they are a fantastic way to solve this. There are many ways. In my paper, I solve it in both ways, in the complicated way and the easy way. I want to show you the easy way. You define u like 1 over x squared. Okay, somehow represent that part. And you define b like 1 over y squared, que represent that part. Now, immediately when you change the variable, this is 3u plus b equals 7. And this is my equation number 1, new, after the transformation. And this is 5u minus 2b equal -3. It's a new equation. And this new system is linear. It's linear. And you solve it like a linear. Like we solve it every day in our life. Linear. Entonces now, if you, for example, multiplication by 2, this equation, because I want positive 2 and negative, ready for elimination, you multiply 6u plus 2b equal 14. This is my new equation 1. Ready, addition by column is 9. 9, no, 11. 11 because it's this and this together. This and this. 11. 11u. This cancel out. And this is 11. Wow. Therefore, u is 1. If u is 1, let me try to find b. To find b, you take either equation. For example, the first one is 3 times 1, que u is 1, I know, plus b equals 7. Therefore, B is equal to 7 minus 3 get 4. Okay, and this is the answer? No, of course no. This is the answer of the intermediate variable that we use to transform it. And so we come back at the beginning because my answer is X and Y. But this is relatively easy because I know that U is 1 over X squared. Look, let me show you. I focus on U equal 1. I substitute here. I have 1 over X squared equal 1. Cross multiply. X squared equal 1. Apply square root both sides. X is equal plus or minus 1. And B equal 4. Here is 4. Is 1 over Y squared equal 4. Cross multiply again. 4y squared equal 1. Y squared is equal 1 over 4. Apply square root both sides. Y is equal plus or minus 1/2. Okay, so we have, I suppose that we have 4 combinations. We have 4 points. Is the point plus or minus 1, comma, plus or minus 1/2. Okay, actually is 1, comma 1/2. Consider both positive. Negative 1, comma negative 1/2. Consider both negative and their combination. 1, comma negative 1/2 and negative 1, comma positive 1/2. In total, we have 4 solutions. To verification this idea, you go to Desmos and verify that. This is one possibility to solve that. Okay, I consider it easy. Let's see the answer in Desmos. Okay, number 10, que es the last one. Here. Look at the equations and look at the graph. Wow. One equation is the black equation. Another equation is the purple color equation. And together they intersect at 4 points. It's the famous point that we get. Any question, guys? Entonces, the super fantastic conclusion is non-linear of equation is crazy. It's crazy. There are no rule. You need to use in your imagination. But fortunately, we have tools, resource to face that. The first one is the Desmos. But Desmos cover the problem in 2 dimensions, so X and Y. So you have 3 dimensions, X, Y, Z. Desmos doesn't work. And we need to apply another resource. So I bring 2 examples. No complicated because it's, this is really crazy. Non-linear is crazy. There are problems ahí que you spend 2 weeks doing that. And never you get the answer. Let me try, come back again to the whiteboard to illustrate a couple of examples of the 3-dimensional non-linear. And let's do the solution by hand because it's relatively easy. And let's do the solution using a new software que es Wolfram Alpha. But I want to explain you more. Okay, so now we come back to the whiteboard. Look here, over there. Okay, erase the whiteboard. What is the thing that we tried now? We have a system in 3D, non-linear in 3D, the systems of non-linear equations, but now in 3 dimensions. In 3 dimensions, the non-linear equation is not Do you remember that in linear equation in 3D, each equation is represented geometrically like a plane? In nonlinear, no. In nonlinear surface. Maybe it's a sphere, you know, or maybe it's something like that, a curve like that, a surface. So now this is, we can using the algebra. You remember that, but it's crazy. It's crazy. Okay, let's go to the point. The point is, after 60, I try to do my best by hand. The system is example 1. We are doing only 2 examples. Example 1 is y equal to xc. We have the third variable, x, y, and z. Equation 1, easy, or relatively easy. X is equal to yz. Equation 2. And the last equation is x squared plus y squared equal 1. Equation 3. We have actually here a nonlinear system of equation in 3 dimensions. Okay. I try to do by hand, and after to verification, we have no decimals because there's more working in the 2D XY plane, and we're using Wolfram Alpha software. This is also in internet. You go to the site. I explain it now, but no. I try by hand because on the test I do by hand. Now Wolfram Alpha help me to verification, double checking, right? Because in this case I don't know how we start. However, I did before, no? Because I know. If you divide the equation number 1 divided by equation number 2, say, Professor, normally you subtract, you know, but in this case division. Why? Why division? I don't understand. Because y over x and the left hand side, in the right hand side, I take advantage to cancel out, look, cancel out that 2 on this z. And you have the equation so far as y over x is equal x over y. Wow. And now cross multiply. Y squared equal x squared. Yeah, I come back to the equation number 3, que somehow relate, you know, x and y squared. Entonces, you copy now. X squared, I leave it like that. Y squared is x squared again because I know that y squared and x squared is the same in this specific example. In other, no. Equal 1. Entonces, combine the term. Equal 1 divided by 2. X squared is equal 1/2. Square root both sides. X is equal plus or minus radical 2 over 2, no? Bueno, square root 1 is 1, square root 2 is radical 2, rationalize. Radical 2 is plus or minus radical 2 over 2. And this is the x value, no? And the y value, I suppose, is the same because x squared 1/2. Look here. In that moment, x squared is equal to 1/2. And y squared is also 1/2 because the same x squared and y squared is 1/2. The only thing I need to find is z value. You plug it in either equation. I don't know why. Well, in the easier equation, in the first one, maybe. One solution is, you know, y is plus or minus radical 2 over 2. Y is the same. X plus or minus radical 2 over 2. X equal to time plus or minus radical 2 over 2 is x. Multiplication by c. It's all because that part cancels. And c is 1/2. Moving this 2 to the other side, division divided by 2 both sides. 1 equal to c divided by 2 divided by 2. C is equal to 1/2. Okay, so how many solutions in total we have in this problem? Wow, I don't have idea. Well, x and y is plus or minus. Actually, we have plus or minus radical 2 over 2, comma, plus or minus radical 2 over 2, this is x, this is y, comma, 1/2. This is z. Actually, we have 4 combinations. Is radical 2 over 2, comma, radical 2 over 2, comma, 1/2. Another combination is radical 2 over 2, comma, minus radical 2 over 2, comma, 1/2. Next combination is minus radical 2 over 2, comma, radical 2 over 2, comma, 1/2. And the last combination is minus radical 2 over 2, comma, minus radical 2 over 2, comma, 1/2. I am not sure. I need to find, see every combination is true or no. And the easy way to prove this is you plug it in one by one into the original equation. But what equation, Professor? Well, number 1, number 2, or number 3. Do you get the idea? In this case, look like complicated, but I try to select super elementary example to illustrate this complicated idea. This is the most complicated part in algebra. A system of equations non-linear in 3 dimensions. This is crazy. However, to verify everything is okay, let's move into the Wolfram alpha. Wolfram alpha. Okay, Wolfram alpha. You see my face now or no? Somebody touched microphone, my microphone, and my camera. Okay. Wolfram alpha, guys. Switching to the Wolfram alpha. Well, it's the same window. Okay, I open the Desmos, but I need to swap the window. Wolfram alpha. There you go. Okay. Let me know if you see or no Wolfram alpha. Do you see Wolfram alpha? Do you see? It's easy. Yes. You open your browser and you put wolframalpha.com. You see this is a homepage, no? For the Wolfram alpha, no? And you have different subjects: mathematics, science, society, culture. We have a lot of information. And you press algebra, no? I suppose. And inside algebra, you have several problems. But you take the easier, not complicated. You take solution, equation solving. And these boxes are unbelievable, are universal. You click here and you change the test to solving something. I only keep the word solve and you copy one by one our equation, our system. The first equation is y equal to, and be careful, it's mandatory, put the multiplication sign, because in the numerical and variable, no, strictly mandatory, but in between the variable, yes, because Wolfram alpha don't understand very well. So you put xy. No, it's x times y, because if you put xy, maybe Wolfram alpha understand it's a new variable xy. No, not good. Now just in case, to make sure, I put x times y. C, sorry, C. Do you understand very well the idea? And you put a space here. You put the word and, because this equation is connecting by and. No? You need to satisfy the first equation, second equation, and third equation. But the conjunction que connecting this equation is and. No? Entonces, and space again, the second equation is x equal to times y times z. Space again in the keyboard, put a conjunction and, because this is the last equation, and the last equation is easy, is x squared, x power 2. This symbol indicates power. Can you press shift and 6 And you have the power symbol exactly like the calculator, no? Que look like a roof of the house plus y power 2 equal 1. And this is my system, just formed by 1, 2, and 3 equations. And press here that button, compute input. Okay, entonces this copy the equation. And this copy the solution. The solution is not rationalized. Look, is negative 1 over radical 2, negative 1 over radical 2, and C is 1/2. And C is positive half and negative half. Actually, we have, this is the 4 solutions. Positive half and negative half. C, and the combination negative positive, and positive negative. Do you understand very well or no? Hey guys, too complicated? Or easy?
Good.
Good, right? Okay. Let's do another example in 3 dimensions. Okay, so now when you take calculus 3, some people need to take calculus 3 here or no? Yes or no? You don't know?
No.
No.
Not me.
No?
No.
Not me.
No, nobody. Nobody need to take calculus 3 because what's your major?
Computer information systems. So this is like the last like hardcore math I have to take.
No. You have to take.
I have to take IT. I can take IT principles for math, but after that, that's about it.
Okay. And other people need to take calculus 2, 1 and 2? Or no? Come on, guys.
No,
Conversation.
not me.
Yes.
Yes, because what is your major, miss?
Computer engineer.
Computer engineer, yes, calculus 1, calculus 2, but no calculus 3. Calculus 3 is for the civil engineer, mechanical engineer, and electrical engineer. Nobody is a mechanical engineer, electrical engineer, or civil engineer here or no? No?
No.
Wow, so forget about 3 variable. Okay, let's do one more. Curiosity. Just curiosity. I told you que this chapter is easy or no. Entonces, I suppose que never I put in the test 3 variable. Okay, not in the 3 variable, no. Okay, the first equation is 2 equal x times y. X times c, sorry. Equation number 1. 1 equal 2 times yz. Equation number 2. And the last equation is x squared plus 4 y squared equal 4. Equation number 3. We are doing similar procedure. You divide equation 1 divided by equation 2. This is a no universal because there are no systematic way, but frequently because allow us to eliminate something. Equation 1 is 2 over 1, no? It's just 2. And the right hand side we have xz and 2yz. Entonces es obvio que at least 1c es cancelled. Entonces my equation so far is 2 equal x over 2y. Or cross multiply 4y equal x. Okay. Now I come back to this here. Substitution here the x. No x anymore, no. It's 4y squared plus 4y squared equal 4. Okay, sorry. I make a mistake, big mistake. This is 4y squared. Because you replace x for 4y. No? 16y squared plus 4y squared equals 4. This is 20y squared equals 4. Divided by 20 both sides. Y squared equals 1 over 5. Therefore, so you apply square root both sides. Y alone is plus and minus 1 over radical 5 over radical 5 over 5 after the rationalization. This is y value. X value is easy to find because it's only multiplied by 4. So x is, you take this expression. Entonces, what is the relationship between y and x? Multiplication by 4. Entonces, it's plus and minus again, 4 radical 5 over 5. Super. And what about z? Z, you take, for example, the second equation, maybe. I don't know why I select this second. There are no rules. Feel free to select any equation. But in my opinion, this is easier. Number 2, 1 here, this equation. 1 is equal to time y, que is radical 5, bueno, plus and minus. Let me use in double sign. Plus and minus radical 5 over 5. And 4 times plus and minus again, radical 5 over 5. Now multiplication. Multiplication is 1 over 2. Radical 5 times radical 5 over 5 is 1/5. It's exactly the same. It's 1. Okay, it's radical 5. Okay, plus and minus. Is our radical 5 over 5 times itself is 5 over 25, no? Is 1 over 5. Plus and minus 1/5 times c. Because I forgot c, no? Okay, no, I make a mistake. Hello. It's, no, not good. Okay, look. This is y. Who is y? Y is plus and minus 4 radical 5 over 5. Multiplication by z. And this is y. Sorry, again mistake. Hello. I'm crazy. Okay, I'm tired. I teaching 3 classes before this. So it's y. Y is radical 5 over 5 plus and minus. And multiplication by c. 2 plus or minus 2 radical 5 over 5 times c. Therefore, c is cross multiply plus and minus 1 over 2 radical 5 over 5. I know that radical 5 over 5 is 1 over radical 5, entonces radical 5 plus or minus, beautiful, plus or minus radical 5 divided by 2. Because I know that this guy is 1 over radical 5, and reciprocal this is radical 5. And how many points? I suppose we have 4 solutions also, no? Include c is equal plus or minus radical 5 over 5. You try to prove or plug it in one by one because we have several combinations. So it's always complicated to find. See, we have 4 solutions or 3 solutions or 6 solutions. Now, the way to verify is easy, but it's too long. So plugging in one by one here and there and in combination. So you get true statement or not. Pero, okay, one more time, we're using Wolfram Alpha, no? Using Wolfram Alpha. Wolfram Alpha, here, over there. Wolfram Alpha. Of course, I'm switching not to the home page of the Wolfram Alpha, specifically the algebra part, you edit our system, no? Solve. The first equation say 2. Do you see Wolfram Alpha or no? Do you see? Do you see?
We see.
2 is equal x times c. So I delete this. X times c. This is my first equation. My second equation is 1 equal to times y and c. It's a coincidence. And the second one, no, is x squared plus 4. We have coefficient 4 here, 4. Or just in case, multiplication equal 4. Now let me check it out, see I do it well or no. Okay. Oh, no, no dollar sign, 4. Just 4. Okay, let me check it. The first equation is 2 equal x times c. The second equation is 1 equal 2y z. Nice. And the last equation is x squared plus 4 y squared equal 4. Done. Solving. Thinking. Boom. You have two solutions only. Two solution works. Okay, -4, radical 5. I don't know why no rationalization the answer. Y is equal to -1 over 5, y radical 5, sorry, and c is negative radical 5 over 2. Nice. And the other is positive, and positive. So the combination negative doesn't work because negative times negative or negative times positive is negative, and the answer that we need is positive. So only work the y and c can have the same sign. Beautiful. You get the idea? Any question? Crystal clear or no? Or confusing? Okay. Answer me, guys. I want you participate in the class. I am boring, see, I speak. Everything is okay? Do you understand the basic idea? I try to make easy. I don't know if I get or not the idea.
I get it, Professor. I was just taking notes.
Yes.
Okay, super. Okay. Okay, sum up. Let's move on to the whiteboard now because I want to introduce. Okay, sorry. New idea. New topic. New topic. I suppose you see whiteboard, right? Okay, now this is the easy, is super easy, in my opinion. I want to show you how you solve that using software. But let's do it by hand and after check it, totally check it with the software. Inequality is the topic. Inequality. And system. En plural, no? Of inequality in 2D. Okay, now no equation anymore. No. Now it's inequality and system of inequality. What is the difference in inequality and system? Inequality is only one. System is 2, 3, 4, 5. Inequality. Inequality together, right? And I promise that when you finish that part, you see the application of this. Fantastic application and different word problems. Let me start for elementary example. Example 1 of that part. Well, first of all, one equation in 2 dimensions is given. Is 3x minus 2y less than 6, suppose. And what's the idea? The idea is find the solution of this. And the solution in 2D represent one area. One area. One is 2 dimension. It's not in only one dimension problem. We have all real number line. And we have one piece. No. No, it's two dimensions. We have X and Y. And you have one region here as a solution. Therefore, what is the procedure? Let me explain in detail. The procedure is you temporary, you convert this inequality in equation. Oh, not necessary now. Well, no, not necessary now. Okay, my recommendation is, first of all, solve for y. Step one, solve for y. Let's do it. It's minus 2y less than minus 3x. I move 3x to the right hand side plus 6. Divided by negative 2, because my goal is isolate the y. So y alone is equal, and you need to know when you divide inequality by a negative number or multiply by a negative number, the sign of the inequality is reversed. Entonces 3/2 positive, minus 3. Okay? This is my first step. My second step is do the graph of related equation. No inequality anymore for a moment. So you convert this equation, this inequality, sorry, to equation. And I try to do my best. Let's do it by hand, but after we see in decimals, of course. To do the graph of this. It's a line, you know, y equal mx plus b. You know que b is negative 3, que represent the y in a set. 1, 2, 3. You plot that point. 0, negative 3. And from this point, I know that slope is 3/2. I know also the definition for the slope is the ratio between rise divided by run. It's obvious that rise is 3. Positive is 3 units up. And rise is also positive, it's 2. Wrong. Sorry, wrong is also positive, it's 2. Wrong is always to the right. So from this point, you move 3 units upward, 1, 2, 3, and 2 units down, 1 and 2. By coincidence, we get that point, get the point 2, 0. Okay, suppose that this point satisfy also the equation. Look, see, you plug it into here. Look, 3/2 times 2 minus 3. Cancel out these two. 3 minus 3 is 0. Okay, no, it's a coincidence. Not always happen. And you are doing the line using my rule. I'm connecting both. The challenge now is what kind of line I do. Solid line or dotted line? Solid line or dotted line? So we have two possibilities. You have two possibilities. You have the possibility of the solid line and dotted line. And solid line is when our inequality contains equal sign. Because when it contains equal sign, the equation is considered inside the solution. Pero no, professor, no. My inequality have no equal sign. That means that the line, the relative equation is not inside the solution. And the symbolic way to indicate this idea is using dotted line. It's like two countries separated by boundary, and the boundary don't belong to any country. or at least the solution. And this line split the plane into semi-plane. And to say we have two possibilities: the semi-plane above or the semi-plane below the line. Okay, there are many ways to do this, to determine this. Using that symbol, see, you see it, my problem. My problem after solve for y, this is important, guys. Step one is super important, solve for y. See, when you solve for y, it's greater than here, the symbol just says above. Above what? Above the line. See, the symbol is like that, it's below. Okay, so you shade that part because it's above. This is the solution, this semi-plane. In this case, it's the completely semi-plane. When you have a system, it's more complicated because you have different inequality and you need to find the intersection. But in this case, it's easy. Entonces, now another way to determine that is using this idea. In my opinion, is good, but some people prefer another idea. Another idea is take one testing point, here or here, and plugging it into the regional inequality and verify see it's true or false. And the famous testing point everyone get is 0, 0 because it's easy. I suppose that you plug in 0, 0, the answer is true according to this rule, no? I don't know. 0, 0. Suppose x equals 0. So I plug it in here. 3 times 0 minus 2 times 0 less than 6. 3 times 0 is 0, minus 2 times 0 is 0, 0 is less than 6. And this statement is obviously true, so I select the correct semiplane. Do you understand? It's super easy, eh? Okay, let's go to Desmo to see that. Let me check in Desmos. I try to find the inequality to dimension basic. Okay, let me switch into Desmos. There you go. Okay, do you see Desmos? Do you see? Look at the first example. Yeah. The first example is, look at the first example. It's easy, yes. 3x, I copy exactly the same. No, in this one, no isolate nothing. You want to isolate, you can. But no, copy exactly the same as given the problem, and you, bam, this is the answer. The blue region is, when I highlight in green color, just like change the color. How you change the color, guy? You click here, hold the mouse, and change the color. Green. End the story. Any question? Look like easy, eh? But no, you know, I am a little bit bad guy. I want to complicate a little bit this. Not too much, but a little bit. Okay, I come back to the whiteboard. And let's do one more example. And that's it. Too much for today. Do you see whiteboard?
Yes.
Okay. Let's do two more. And that's it, I promise. Okay, it's very, very similar. Example 2 and example 3. In this case, no, it's non-linear. Suppose x squared plus y squared less than or equal 4. And this is similar. It's x squared plus y squared greater than 4. I have no idea. I have no idea. And this case is crazy. So for why? Because there's no linear. And then immediately I convert to equation. Is x squared plus y squared equal 4. Okay, by the way, this equation is using for this example and for this example. It's the same, no? When you change the inequality sign for the equation. And you identification. What is the curve to satisfy this equation? Call it algebra. It's a circle, no? It's a circle where the center is located in the origin 0, 0 and the radius 2. 1, 2, 1, 2, 1, 2, and 1, 2. Circle. Let me try to do my best. Don't worry. And this way I'm doing better. This is 2. This is 2. This is negative 2. And this is negative 2. Entonces, this curve no separate into semi-plane, separate in one closed figure. Entonces, maybe it's inside the circle or outside the circle. What do you think? The solution for this? What do you think? Is inside or is outside? What do you think? What do you think? I don't know. I don't think. I applied testing point. Testing point. What is the famous testing point? 0, 0, no? 0, 0. Plugging in x equals 0 and y equals 0 here, que es the origin here. If the origin satisfies this equation, does it belong to the inner part? 0 squared plus 0 squared less than or equal 4. 0 squared plus 0 squared, 0 less than or equal 4. This statement is true or false? What do you think? True or false? Hey, it's true. It's true. Entonces es the green part, the region, the closed figure inside. And what do you think about the boundary in between? Is included inside or no? So this is green or no green? Include the boundary or no? What do you think? Include or not?
Included.
Include or no?
No.
Why no?
Because there's still positive in the top right side.
Okay. You see equal sign here? Equal.
Yes.
Entonces now, the equation when it's equal is exactly the circle, que es the boundary here.
Oh, I got it.
Entonces incluye. And what do you think about the example number 3? Is inside or outside?
It'd be outside.
Inside. Incluye the boundary or no? In this case.
No, since it's not equal to
No. So in the blue, no. Entonces the way to indicate this is dotted line. Okay, let's see elegant answer in this one. And that's it. Let's go to Desmos. Share. Desmos. Do you see Desmos? Do you see? Yes or no?
Not yet.
No.
Not yet. Okay.
We could.
Do you see now?
No.
Do you see now? No.
Yes.
Yes, no. You need to wait a little bit to see. Look quickly because the time is over. Number 2, bang. It's a circle. Look at that. And the equation, I put an equality like that. Look. And example 3 is the same inequality but greater than. Now let me delete that part. You see the dotted line? Do you understand very well? Outside, dotted line. Inside, solid line. Super clear?
Yes.
Yes.
Excellent. Bueno, guys, I love you so much. We finish. Have a nice weekend.
Thank
Goodbye,
you.
Professor.
Thank
You
you.
too, Professor.
Bye.